we did some performance measurement of some public clouds to try and figure out where we stand, how our customers compare against public clouds, what do we need to improve in our system to beat them, right? And these are some, like very little about the methodology behind it. We got basically identical virtual machines from a bunch of public clouds. These virtual machines have 8 vCPUs and 16 gigs of RAM. And we got acquired kind of storage block volumes from these public clouds. Most of these clouds don't have a single offering between 10 and 20 cents per gigabyte. It's only Google Cloud since recently, since a couple of months back, that has 2 offerings between above 10 cents. Amazon has a kind of a provisioned IOPS offering, but that's extremely expensive. That's like 6 cents per IOPS. So we don't have it here because it would be like 5 times more expensive than any of the other storage volumes that we compare. So what's the goal here? We want to see on essentially identical compute. We're trying to make the compute as similar as possible. So these are dedicated CPU cores. They're not shared with someone else. There is the same amount, so 8 vCPU, 16 gigs of RAM. And we run these tests in different clouds and try to see how these different offerings compare. Price-wise, they're not exactly the same, but they're close to each other, right? Okay, how do we run these tests? Here is a link to our website where you can see kind of the previous version of our test suite. And we will be updating that because we have some newer scripts and updates to our method in there. And if you want more information about this, drop us an email. We'll have like a full write-up on this, but if you want the information before that, just drop us an email. So it's FIO, rsync. We use rsync to simulate kind of a deployment or backup type workload. We use pgbench and sysbench for transactional workloads. These are both storage and CPU heavy. So some of their kind of, sometimes they would be limited by the CPU of the VM, other times they would be limited by the storage. And in future versions, we would have like a dedicated CPU benchmark to make sure that the CPUs we're getting are actually identical, that they're not very different from each other, right? And we are thinking of adding a network benchmark, but that complicates things a bit. So these are the first results. And these are some, just 1 second, please. All right, so these are some of the public clouds. You can see Amazon EBS and Google Cloud and the cheaper Google Cloud persistent disk, Azure and DigitalOcean. This is again presented as it's a pgbench benchmark with a database which is 4 times the size of memory. So it's not kind of a memory only benchmark. And it's presented as latency for a certain number of transactions per second. So it's kind of, if your workload looks exactly like pgbench and it has 4,000 transactions per second, then your only option between these public clouds is to run into a Google persistent disk in Google Cloud. You can also go to Amazon and for maybe 60 or 70 cents per gigabyte, get a storage system that's suitable for it. But it's unlikely you're going to do that because it's just way too expensive, right? The first thing we learn from this is that all of these offerings are not fit, they're unfit for running databases. If you have any kind of production transactional workload, that's not 2 transactions per second. Any real workload in thousands of transactions per second wouldn't be able to run on DigitalOcean or on Azure Premium SSD. It would be able to run only on Google Cloud SSD persistent disk. And the part that I haven't shown on the chart yet is how we and our customers' clouds perform. So the green thing is a StorPool private cloud, which is a fairly small environment that we do test and dev in. It's fairly loaded with all kinds of kind of build systems, test systems, etc. And it's the only one of these offerings which doesn't have a price associated with it because we're not selling it directly, right? And the other one is one of the three case studies I mentioned earlier. The Catapult service offers virtual machines with StorPool-based NVMe block storage for 15 cents per gigabyte. And this is how pgbench behaves on their public cloud service. Now, there is this is just a zoom in of the same chart so I can show a couple of things. There is a significant performance difference between the fastest of the public clouds, which is Google Cloud with SSD per system disk, and the service of our customer. That performance difference translates into a 3 times latency difference for transactions on top of the database, right? And in other terms, if you compare throughput instead of latency under reasonable load, you would get about 2 times more transactions per second with the same specification of a virtual machine, with the same amount of money spent on compute. So if you have a situation where seemingly the same virtual machine delivers twice as much performance, we claim this is caused by the faster storage system that Catapult uses, right? So Catapult VM is much more capable for the same, like you go to them and you pay them, say, $100 for a VM. You go to Google Cloud and you pay $100 for a VM. You can do twice as much work in the Catapult VM that you can do in the Google Cloud VM, right? This is roughly the claim here. In the next test, we also show that even if the database is smaller than memory, there are still very large differences. So transactional workloads depend on, like the performance of transactional workloads depends on storage latency significantly, even if it's just in memory. So some of these are commits to disk. Like part of these transactions need a commit to the journal of the database, and that's storage latency bound. We do the same kind of test with the completely different database. So it's not PostgreSQL, it's MySQL in this case with sysbench. And it looks pretty much the same. So under a particular load, so say the load is 200 transactions per second of this kind of transactions, right? You would still get 2 times lower latency on one service than you would get on the other. This is the rsync benchmarks. In them, there are 2 of them. One is copying 3 million files from one directory to another directory, right? And it's measured in megabytes per second. And you'll notice it's only 60 megabytes per second. And the reason for this is real applications, and they have very kind of complex behaviors that limit their performance. They're not, they're not a perfect storage benchmark. They do a lot of other stuff. They don't just load the storage. And so you get a smaller differences, so which is like, say, 60 megabytes per second on one versus 50 megabytes per second on the other. And then resyncing these files, which means verifying their timestamps and kind of traversing the whole directory tree. You could do that at about 40,000 files per second on StorPool-based systems and at only 10 or 15,000 files per second on the other public clouds. And the second benchmark is latency bound, storage latency bound. So like round trips to the storage. Every time they enter a directory, they need to do another read from the storage system. And these are the kind of your usual FIO familiar benchmarks. Top and bottom chart show the same thing, just in different ways. One is latency under a 4K QDepth1 workload, and the other one is IOPS under a QDepth1 4 kilobyte block size workload, random reads, random writes, right? So you could see the StorPool-based service delivers 100 microseconds latency to a virtual machine. And the second best you can get in a public cloud is like 300 microseconds or 400 microseconds latency to a virtual machine, right? These are the IOPS numbers. So you could get 100,000 IOPS to a VM, or all of these are kind of IOPS limited. So say the Google, the Google Cloud SSD persistent disk is IOPS limited to 15,000 IOPS per second. If you want more IOPS, what you do for this specific service, if you want more IOPS, what you do is you get a larger disk and you get more IOPS. So it's kind of the IOPS limit you get is depends on the size of the virtual disk you get from these services. And similarly, the last synthetic benchmark we run is sequential reads, sequential writes. On a good StorPool-based system, you could get like 3 gigabytes per second to a virtual machine, right?